All right, our objective for the day is I can simplify and evaluate algebraic expressions using order of operations. Read together, 1, 2, 3. I can simplify and evaluate algebraic expressions using order of operations. So we started this yesterday, and pretty much it's just simplifying expressions, right? And today we're going to continue with some of this, but I want to revisit a worksheet or a tool that in the past your teacher probably introduced during 7th grade. Hopefully they did. Today I'm going to continue with that. So, tell your neighbor that what concept we're still on. Very good. I said concept, not objective. Tell your neighbor the concept. All right, algebraic expressions. So, the question, and this was a question from the home plate, how do I evaluate and interpret algebraic expressions? So first of all, how do we evaluate? The first thing was to substitute values, is that correct? And then simplify using order of operations. How do you interpret? Well, depending on the word problem that you get, the expression depends on the context that they give you. So you just say, you interpret by answering the question to a word problem or to a real world problem. In any other words that you might have put that, okay? And then from there, yesterday we did an intro using concert and so on and so forth. Remember that? And then we said numerical and algebraic expressions. And then in your FAIR model, you wrote algebraic expressions. And then you're writing the definition right now without looking at your notes. See how you do. Algebraic expressions. See if you remember. If you don't remember the definition, start writing examples to see if your noodle starts turning a little bit. Do that. So once again, you wrote somewhat your definition, examples, non-examples. So turn around and talk it over with your neighbor and see if they have the same definition as you, some examples and non-examples. Okay, let's see how well you did. Here we go. Just in case this was a partay, let's see how you did with the FAIR model. Algebraic expressions are expressions that contain variables, constants, and operations. Okay? And then some examples, you should have written some examples that had operations with a variable and a number. Non-examples, you probably wrote an equation and an inequality. You don't have to write all of these, but at least one of each or something like that. And the critical attributes were that they need to contain what? Variables, numbers, or constants, and operations, no equal signs or inequality signs. All right, so we don't need steps since yesterday we already wrote the steps. But I also revisited terms, like terms, coefficients, and constants. Remember that? So you can finish the rest of it by yourself. But yesterday, like I said, I revisited terms. What are terms? That are the parts of an expression, and how do we know, bless you, when one ends or begins, and it's wherever we see addition and subtraction in between the expression. Like terms are the ones that have the same variable raised to the same power, and a constant is basically a number without the variable. So for example, I gave you guys 4x minus 3x plus 2, bless you. Here, how many terms do we have? 3 terms. What are the like terms? 4x and negative 3x. Like terms, therefore this is the constant. And whenever you have a variable, you have a coefficient. The coefficient here is 4, and this one is negative 3. Negative 3. However, if the variable does not have a number, what is a coefficient? 1. We saw that yesterday, right? All right. Then I gave you guys an expression to see how many terms it had. And then the home plate had some of these questions in between, didn't it? Something like that? And then you did one by yourself. From there we went to do some, wrote down the steps. From there we did some revisiting order of operations. Remember that? And then from there, we went to do some practice. Okay? So now, I gave you guys one with evaluation where you just wrote the expression and you substituted values. Remember that? So that brings us here. Let's do some practice on combining like terms. Write this one down. Example 3. Simplify the expression by combining like terms, 72p minus 25p. All right? And the reason I'm revisiting this so that we are aware that we are doing what? Combining like terms. When we combine like terms, we're basically adding or subtracting. And what does that mean? That we don't do anything to the exponents of the variables. Is everybody clear with that? We don't do anything to the exponents of the variables. I'll put a little asterisk and a heart. Oh. So what do I mean with that? That means if we put a 1 here, we don't combine the exponents because here we're combining like terms, which means it does not involve multiplication. So if this is the same as this, same variable, same raised to the same power, we just write it once, and then we just use the coefficient. 72 and negative 25, that is 47p. Hands up, you got that? Yeah, we got this, right? The reason I'm clarifying, because once again, some of your noodles are getting stuck when we do the area model. You forget to switch. We multiply first. That means we do stuff with the exponents. But then you need to switch your brain to think, now I'm going to add and subtract, which means I don't do anything else with the exponents. Does that make sense? Yes, Mr. Hugh. All right, good. Copy this one. Example 3. For example 3b, you don't have to write the instructions since you already wrote them. But example 3b says 3/4 x to the 4th plus x to the 4th. Simplify that by combining. All right. Let me get somebody to help me out for this one. How about Olivia? What'd you get? Okay, let's see. So 3/4 x to the 4th plus x to the 4th. Okay. Are these the same variable? Yes. What is the coefficient here? So therefore, 3/4 plus 1 is. Thank you, Olivia. You have a deep voice. 1 3/4. Sands, have you got that? Okay. So do this next one, please. 20 seconds. Example 3. Go. All right, let's see. Haven, what'd you get?
0.5m plus 2.5m.
She basically read me the same thing. Why didn't we combine different variables? This is m and this is n. Okay? So, last one. Copy these, please. Do those. Give you guys about 1 minute. Go. Okay, let's see. Francisco, what'd you get for A? Huh? For A, 100p, yes? B? Negative 28.5t. And for C? M cubed plus 2m squared is correct. If you wrote it the other way around, I would have taken the point off. You need to start writing it in standard form. Remember that? Yes, Mr. Q. All right, good. All right. So we got this, right? All right. So now we get to the next portion. Window notes. Yay! So did everybody get a blank sheet of paper? Okay. So here we go. Please follow along because I don't want anybody to get lost with this. So have this in front of you like this, portrait style. Are we there? Okay. So then we're going to fold in half. So we fold it in half. Let's see if I can get. Okay. There it is. So we fold it in half, and then from there, fold it in half one more time, like so. The other way. Be nice. Okay. So then from there, you open it up, and guess what? Bam, window nose. Everybody see that? Okay. So what I'm going to do, I'm going to get my marker and show you the creases so that you see exactly how it should look. Something like this. Okay? So at the top left, I want you to write problem. On the top right, process. On the bottom left, sources. And on the bottom right, summary. Problem, process, sources, summary. Problem, process, sources, summary. Problem, process, sources, summary. So guess what goes where it says problem? The problem. Here we work it out. But the process, I need you to explain it using properties. So if you want, right next to it in parentheses, just write properties. Because by now we've been practicing our properties, right? Yes, Mr. Q. All right, good. Now the sources, what does that mean? Whenever you're at home and let's say I ask you to solve a certain problem and show me in window notes. Let's say you get stuck and you need to go somewhere to look for help. Where is the first place that you look for? Yes. Okay, YouTube channel. So you write 23 Mr. Q YouTube channel. Where else do you go? Brother. There you go. Does anybody look at their textbook for examples? Yeah, right. Textbook. How about your Cornell notes? Cornell notes. You write that in here, Cornell notes, and you write the date of the Cornell notes so you can remember where to look for. Does everyone understand that? And I'll show you how to fill out the rest. So for right now, I'm going to go ahead and give you a problem to write in here. So check this out. Let me minimize this really quick. Let's see. All right. So write that in there in the little window that says problem. And let me put the camera up so you guys can see what I'm talking about. So I'm going to write that right here. So it looks something like this. What's it say? Use properties and operations to show that what else? 14x. Make it a little bit bigger. The 14x, the expression that they give us, plus 4 parentheses, 2 plus x. You're going to write simplifies to 18x plus 8, period. See what I did right there? So basically you wrote the problem there. So, let me ready my colors. So let me ask you a question. Where did we get that problem from? From me. That means I gave you the problem? Is that correct? So whenever you start a window note, the very first thing you should write is given. Given. Get used to that. When I ask you to solve a problem using window notes, you go to your text, you go to wherever I send you, you need to grab it from there, and the first step is given. Yes. Okay, we'll take points off. Everybody say thank you, Sergio. Thank you, Sergio. All right, so with that said, this is what we're going to do. From there, let's rewrite the expression. Look up, please. Write the expression with bigger numbers and letters. 14x plus 4, parentheses, 2 plus x. And we're going to simplify that using properties, okay? So think about it. Look at this expression. Turn to your neighbor, let them know what would be the first thing you do. First thing you do. Yes. Thank you. Yes, I know. I it's something that stays with me forever. Forever. All right. So, everyone, what is the one thing that we do here? Get rid of the parentheses. So what is that property called? So write that in here, distributive property. And I'm going to use red to show with arrows here also to distribute in here. So I'm going to do that step in red. So I got, this is 8. And then I got plus 4x. And then I bring down the rest, 14x, and then the plus. All right. So, we got up to right there. Look at it. What would be the very next thing that you do? Tell your neighbor, please. Okay. I heard combine like terms. However, those are not properties. What properties, think about it, what two properties do we use to combine like terms? Tell your neighbor. Talk it over. Talk it over. So, the first property was what, boss? That would be the second one. The first one is commutative. So right underneath commutative, property of addition. So I'm going to show that step with green. Hold on, Santiago. So we got 14x, and what that means that we move stuff around, plus 4x plus 8. All right. What is the second property, Santiago? Associative. So underneath that, associative. Property of addition. I'm doing that in blue, which means I group these, and now I can combine. So what is 14x plus 4x? That's 18x plus 8. All right? Can we do anything else? No. So at the end, let's just write simplified. Simplified. All right. Pretty good? Okay, let me zoom in so you guys can see that. Damn, the colors, right? Yeah. I know, but last year was last year. Now we're in algebra. Now we're going to show all steps using properties. Is that correct? Yes. To combine like terms, I want you to show me the steps using these two properties. Thank you. Yes. Okay, we have to write those two down. Everybody say thank you, Santiago. Thank you, Santiago. All right, so with that said, now let's fill in the last box down here. Now check this out. This is where we're going with all the teachers here in Frank Wright and throughout the high school. If you look over there on those books, which is the next course that you're supposed to take? Geometry. Well, guess what? The first 3 chapters of geometry, they show you this. This is called 2-column proofs. So you need to show a process, and you need to give the excuse using a property. However, after that, they introduce something else called a paragraph proof. What does that sound like? Writing an essay. So guess what we're going to do at the summary? Yay! So here we go. Down here. Nice. Down here, I want you to write, anytime you start a summary or a paragraph proof, you need to write, I was given. I was given. What were we given? The expression. Let's write the expression that they gave us. 14x plus 4, parenthesis, 2 plus x. To do what? To simplify to, what was it supposed to simplify? 18x plus 8 using properties and operations. You don't. You just reiterate it, but in a way that you're presenting it to someone and explaining it to someone. What? Oh, yeah. What was the question? I'm sorry. I missed it. No question? Okay. All right. Hey, that's a good idea. Anyways, here we go. So, are we there so far? So let's see. Our paragraph starts. I was given 14 plus 4 times 2 plus x to simplify to 18x plus 8 using properties and operations. Okay. So what did we do? Okay, but if you're writing a paragraph, what would you write here? First, I, what? Distributed 4, I'm going to write the number 4, into the parenthesis. Bam! Everybody say thank you, boss. All right, well, yeah. It's kind of, yeah. All right. First, I distributed 4 into the parenthesis using, what property did we use? Distributive property. Property. Distributive property is multiplication. Let's try. Okay. What would we write next? Bam. Secondly, is that time? All right. Secondly, what did we do? Combine. Secondly, I combined like terms using the commutative and associative property of addition. Finally, I simplified. Don't forget to write 10Q.
What does that mean?
Thank you. Your home plate for tonight is found on pages 61, numbers 1 through 13, and 63, numbers 23 to 32. Have a good one, everyone. Enjoy your home plate. See you guys tamales. Bye.